This fun fact is for the first actual official fall day of 2024. It's that time again, back to school, back to life being scheduled, and yay, back to the Sunday night astronomy show. This show coincides with the day of the fall equinox, but not the time of it. The official Atlantic time was 9:34 a.m. this morning, or, back on September 22nd, depending on when you are listening to this fun fact, right about when many of us were on our second cup of coffee. This year's equinox is rather special in that it marks the earliest time for the start of fall in 228 years. How's that? You might want to grab a pencil and paper, as this first fall fun fact may cause some befuddlement. As you know, the Earth follows an elliptical path around the Sun. The planet's rotational axis, the imaginary line that runs through the north and south poles and is tilted with respect to that path by roughly 23.4 degrees. Earth doesn't wobble back and forth by that much. The tilt is fairly constant, such that the North Pole always points roughly towards the bright binary star Polaris. This consistent tilt, along with our world's motion around the Sun, are the reasons for the seasons. That sounds almost like a Peter, Paul, and Mary song. We don't feel this tilt from here on the surface, since gravity is constantly pulling us toward the planet's core. However, we do see its effects. The most directly noticeable impact is how high the Sun reaches as it arcs across the sky each day throughout the year. In this solar graph image, each arc across the image is the path the Sun took through the sky, with one arc accounting for each reasonably clear day between June 21st and December 21st, 2023. The highest arc is the summer solstice, the lowest is the winter one, and the one in the middle is roughly when the fall equinox took place in 2023. While the equinoxes and solstices happen around the same time each year, their exact day and time are never the same. Partly this is due to Earth taking a slightly different elliptical path around the Sun each year, thus changing the exact time it takes for the planet to complete that orbit by several minutes either way. The rest is because mankind created a 365-day calendar to track the 365.25 days of time between one spring equinox and the next. So far, so good. These 4 views of Earth from satellites in space show our planet from left to right during the northern summer solstice, fall equinox, winter solstice, and spring equinox. The result of roughly 6 hours of extra time, coupled with our use of leap years, produces a very specific pattern in the timing of the equinoxes and solstices. Each year, for 3 years in a row, these astronomical milestones occur nearly 6 hours later than the year before. Then on the 4th year, specifically the leap year, their timing shifts backwards by roughly 18 hours. Over the past century or two, on most years, the fall equinox has occurred on the 22nd of September, with the occasional one happening early on the 23rd. However, ever since the year 2000, we've seen an interesting new pattern. Each time we have a leap year, the equinoxes and solstices set a new record for the earliest we've seen. Why is this happening? Before the year 2000, whenever we've come around to a century year, like 1800 and 1900 specifically, it hasn't counted as a leap year. Normally it would, as we can evenly divide those years by 4, like every leap year. But there is an additional rule for leap years, where we do not count any year that is evenly divisible by 100, but not by 400. This second rule compensates for a bit of extra time that all the other leap years add to the calendar. But adding a few extra seconds is quirky, a bit like not spaying your 2 kitties. Yes, that's actually 80 million plus pussycats in only 10 years. Fortunately, skipping the potential leap years 1800 and 1900 did not cause an extra 80 million seconds or 22,222 years. But it did mean that the equinoxes and solstices didn't shift back by 18 hours. Instead, just like in the previous 3 years, their timing advanced by nearly 6 hours. this has thrown a little kink into the timings, and the result is a few earlier equinoxes. The last fall equinox that was earlier than today's, which is September 22nd, 2024, was 228 years ago, back on September 22nd, 1796, when it occurred at 3:06 a.m. local mean time, which is roughly equivalent to Eastern Standard Time. This isn't the absolute earliest fall equinox, though. Up until the mid-1700s, due to centuries of counting every fourth year as a leap year without exception, the timing of these astronomical dates had wandered backwards by about 10 days, with the fall equinox occurring on September 12th in 1751. They will continue to get earlier and earlier every fourth year going forward, right up until 2096. That year, the fall equinox will be at 6:56 p.m. Eastern Daylight Time on September 21st, the earliest since the calendar reset in 1752. So there you have it, clear as mud.